to continue to talk about similar figures, but we're going to take a look at similar figures not in the coordinate plane. But figures not in the coordinate plane have the same properties as figures that are in the coordinate plane. So recall that when figures are similar, what do we know about their corresponding angles? They're the same. They're congruent. We use this symbol for congruent. And then what do we know about the corresponding sides? Are the corresponding sides congruent? No, very good. They're proportional. The scale factor of similar figures is the same as the scale factor when we did the coordinate plane. It's just the ratio of the corresponding sides. That's all it is. When you take one side, put it over the other, you get a fraction. That's the scale factor. We use this symbol, it's like that mark, to indicate that figures are similar. So to show that figures are congruent, it's the equal sign with that squiggle mark above it. To show that figures are similar, we just use that symbol. So we take a look at this first example. It's saying triangle ABC is similar to triangle PQR. We're going to state what we know about the corresponding sides and angles. So if we know they're similar, we just said it, the corresponding angles are similar. So let's start with angle B. What angle does B correspond to in the other triangle? Q. You can tell by visually looking at it. You can also tell by the similarity statement. B and Q are both the second point, so B and Q match up. So we know B and Q are congruent. Angle B is congruent to angle Q. Let's go to angle C. What angle is angle C congruent to? R. You can tell visually also C and R are the last letter, so C and R are congruent. They're the ones that match up. And then lastly, A, what's A congruent to? A and P are both written first. They're also in the same spot in each triangle, so A is going to be congruent to B. So we know when we have similar figures, the corresponding angles are the same. They're going to be congruent. We just said their sides are proportional. So we know we can make a fraction out of their sides. So give me one side, it doesn't really matter. Give me a side in this first triangle. This first little triangle. BA? What side corresponds to BA in that other triangle? PQ or QP. Okay? So I know if I make a fraction BA over QP, that's going to be equal to all the other sides made as fractions. How you can tell visually they're in the same spot, but sometimes the triangles aren't oriented in the same direction. So how else you could tell? This line right here goes from one arc to three arcs, and the triangle goes from 1 to 3. The other side that goes from 1 to 3 is also going to map up with it. Okay? So then pick another side, go back to the original triangle, pick another side in that first triangle we used. BC. What side matches up with BC? Yeah, QR. B to C, Q to R. From B we go from 1 to 2 arcs. For QR we go from 1 to 2 arcs, so they match up. BC over QR. Very important, you have to stay consistent. We started with the little triangle in the top for the first fraction, so the sides of the little triangle have to stay at the top of all my other fractions. You have to be consistent. If you're not consistent, then you're not saying the right things are congruent to each other. And then what's that last ratio going to look like? What are my last sides? Yeah, it'll be AC over PR. Again, visually when you look, AC goes from 3 arcs to 2 arcs. PR goes from 3 arcs to 2 arcs, so they match up. AC C over R. We have similar figures. Corresponding angles are always going to be congruent, and their sides are proportional. Meaning you can make fractions out of the corresponding sides, and that fraction will be the same. Questions over that? So now let's take a look, and we're going to determine if figures are similar. If they are, we're going to write a similarity statement and find the scale factor. Okay? So if we look here, I have three sides. Well, first, when we're trying to identify if figures are similar, look at the angles. Okay? Do we have angles that have the same arcs in each triangle? Yeah. Right? We have an angle with 1, 2, and 3 arcs in each triangle. They're not oriented the same way. They might not necessarily look like they're in the same spot. But we have corresponding angles that are the same. Right? That's first step. Your next step to see if they're similar is you will also have to see if their sides are proportional. Because figures could have congruent angles, but their sides might not be proportional. So you have to check that spot as well. So first check the angles. We have corresponding angles that are congruent. Now we have to see if we have proportional sides. So I have three sides, so I'm going to make three fractions. I, generally speaking, just go from left to right. Okay? So I'm going to start with a triangle on the left. It doesn't really matter which one you start with, as long as you stay consistent. I'm going to start with the one on the left. Okay? Give me one side, it doesn't matter. What side do we want to start with? AC. Okay? The length of AC is 8. Okay? And I notice 8 is in between two arcs to one arc. It goes from 2 to 1. What side matches up in that other triangle? DF, right? Because DF has 1 to 2 arcs, and the length of DF is 10. It's really important. You have to simplify your fractions. You have to. It's not optional here. You have to do it. What does 8 over 10 simplify down to? 4 over 5. So all my other fractions have to be 4 over 5 in order for these triangles to be similar. So now, what I also like to do is scratch numbers off as I go so I don't get them mixed up. So I already used 8, I already used 10, they're done. I can't use them again. So I'll go back to the triangle that we started with in the top. So you have to go back to the one on the left. Give me another side. Doesn't matter. AB? AB is 12. 12 is in between 2 and 3 arcs. Which side matches up in the other triangle? DE is in between 2 and 3 arcs. DE is 15. What does 12 over 15 simplify down to? 4/5. So we have to keep going. Just because 2 of them work doesn't necessarily mean the third one's going to work, so you have to check the third one. We use 12, and we use 15. So how do we have to set up that third fraction? 16 over 20. You have to be consistent. We went from little to big, so we're going to do little over big. What does 16 over 20 simplify down to? 4/5. Did we get the same fraction every time? Are these triangles similar? Corresponding angles are congruent, sides are proportional. You got the same fraction. Okay? So we're going to write a similarity statement. To write a similarity statement, okay? Name the first triangle however you want to name it. Triangle what? How do I name that first triangle? ABC. Triangle A, B, C. It's similar to, so we make our squiggle, you have to name the next triangle in that same order. So we said A, B, C, 2 to 3 to 1. How do we have to name the other one in the same pattern? Yeah. A, B, C, 2, 3, 1. D, E, F, 2, 3, 1. Same order. The scale factor is just the fraction that you got every single week. Okay. So our scale factor is just going to be 4/5. Or 5/4. Why not 15? Because we could take the big triangle, multiply it by 4/5, and that will give us the little triangle. Or we can take the little triangle, multiply it by 5/4 to get the big triangle. So it doesn't really specify which triangle we're growing and shrinking. So I will accept either as an answer. Yes?
Could you leave it as, like, could you make a decimal with it?
Technically, but leave it as fraction. That's how mathematically we look at proportions. So I don't know if they're picky about it on the OSC, but leave it as fraction.
Good.
Yep. Good question. Yeah, if you said 0.8 or point, I don't know, other decimal, but leave it as a fraction. Get used to working with fractions. Can we take a look at B? Let's try this again. Do I have, check my angles. Do I have corresponding angles that are congruent? Yeah. So now we have to check our sides. I have 4 sides, so I'm probably more than likely going to make 4 fractions. Go left to right. What triangle? What shape? It's not triangle. Which side do we want to start with? JM. JM is 6. That is in between 2 and 1 arc. Which side maps up with JM in the other figure? TW. 2 and 1, which is also 6. What does 6 over 6 simplify down to? So you already used these. What other side do we want to use? JK. JK is 12. Good, we have to go back to the one we started with. Which side matches up with JK in the other figure? TU. Again, JK, 2 to 90 degree angle, 2 to 90 degree angle. So it'll be 6. What does 12 over 6 simplify down to? Can we stop? Yeah, why can we stop? Yeah, they're not the same. 1 is not equal to 2. Therefore, they're not similar. Their sides are not proportional. We didn't get the same fraction. If you do the other sides, same thing will happen. The other fraction, if we map up these two, it's 24 over 16. Well, that simplifies down to, what, 3 over 2? And this one is 24 over 14. Well, that simplifies down to 12 over 7. None of those fractions are even the same. All of them have to be the same. None of them are the same. So no, it's not similar. The sides are not proportional. You don't get the same number when you simplify. So if it's not proportional or not similar, do we need to write a similarity statement? No, we can't because they're not similar. Do they have a scale factor? No. So leave them blank, or you can just do like n/a. Not equal. You can apply anything there. They're not similar. Just circle no and move on. Questions over there? Yes.
Could you also tell those are not similar because since the first one is 6 over 6, that would mean that if they're all like that,
Then it has to be the same. Like, yeah. That's another way. Show mathematically the fraction. But Joe's logic here was, well, if the scale factor is 1, that means all the figures are congruent. Because if 2 figures are similar and they have a scale factor of 1, that means it doesn't change at all. So all the sides have to be the same. Clearly, all the sides are not the same, so the scale factor is not going to be 1. But just show mathematically those fractions. Okay, back up 3. Questions over that? Okay. Well, you'll be happy to know there is a shortcut to this. But the shortcut only applies to triangles. You can't use it for any other figure. You can only use it for triangles. Doesn't work for other figures. Okay? But what this shortcut says, instead of having to show all the corresponding angles are congruent, and then all the corresponding sides are proportional. So instead of having to do all this work that we did in A, example 2A, the shortcut is we just have to show that 2 corresponding angles are congruent. This only works for triangles. All you have to do to prove that triangles are congruent is just show that 2 corresponding angles are the same. If you have 2 corresponding angles that are the same, those triangles are automatically simpler. You don't need to do any more math. Okay. We call this shortcut angle-angle similarity. We like to abbreviate it A squiggle. Angle-angle similarity. You see it written like that. A stands for angle-angle, and that squiggle stands for squiggle. And then in that box is just the formal definition of angle-angle similarity. We're going to show that two angles, corresponding angles of two triangles, are congruent, and those two triangles are similar. So let's apply this. We're going to determine that the following triangles are similar. We're going to justify your answer. Our work justifies your answer. So you have to show your work with these types of problems. Okay? Well, again, we can use that shortcut. We don't need to worry about the sides being proportional with triangles. Okay? All you have to do is just find their angles. Well, do we know at least one set of angles are the same? Yeah. Which ones are the same? E and L. They're both 102. Well, F and N aren't the same, but we don't really know anything about the measures of G and M. Okay. So let's find those angles. Let's find G. How would we find the measure of angle G? Yeah, very good. All the angles of a triangle add to 180. So we can take the other two angles, subtract them from 180, and what do we get? Now, do we have two angles that are the same? Do we need to do any more math? No. N is 48, G is 48. We have two angles that are the same. So what can we conclude without having to do any more work? What do we know about these triangles? They're similar. So yes, they're similar because of angle-angle similarity. We have two angles that are the same in each triangle. You don't have to write this super formal definition. Your math shows me. If you do the math and show me that, oh, G and N are 48 and E and L are 102, and put yes, angle-angle similarity, I will understand what you're talking about. But if you just say yes, angle-angle similarity, and you have nothing written down, you just plug everything in your calculator, you're going to lose points. Because I don't know if you just guessed right and got one. Right. You have to make sure you show the math. So take a look at B. Well, I know T and X are the same. But they really didn't give me any other information to find the measures of the other angles. But looking at the diagram, did we see two angles that are the same? Yeah, what two angles are the same? W? How do we name angles? We know T and X are the same. Which one? U. In both triangles, right? This angle right here, TUW, and XUV, aren't those angles are the same? Why are they the same? What type of angles are those? What do we call them? Vertical. Yeah, we have vertical angles. And we know vertical angles are always congruent. We don't need to know the exact measure of the angles. We just need to know that they're the same. Did we show that two angles are the same? Yeah, so are these triangles similar? Yes. So we would say yes. Angle, angle, similarity. And again, marking the diagram shows me that you know those are the same, which shows me that you know two angles are the same. So your work in this problem is just marking those angles. Putting arcs on the angles. Or writing out in sentence form that those two angles are the same. Let's take a look at C. C is very similar to A. I see that B and E are congruent. We need to figure out the other angles to see if they match up or not. Again, how are we going to find the measure of angle C? Subtract them from 180. 180 minus 81 minus 60. What do we get? That map up? No. Well, if this doesn't map up, is that going to map up? No. So you can actually stop. If you're unsure, double check. You can also do 180 minus 40 minus 81 to get what? Yeah. know this angle is 59? We only have one set of angles that are congruent. So are these triangles similar?
No.
No, not similar. And again, the math, doing the math, is showing me that only one set of angles are the same, so they're not similar. So math is backing up your answer. That's your explanation. Make sure you're showing the math. Yeah, only B and E are the same. None of the other angles map up. So these aren't similar. You have to have two. Because if two angles match up, the third one automatically matches up. Which means if all your angles match up, then all their sides are going to match up. What about D? Are these two triangles similar? Yeah. Do you have to even do any work here? No, I don't know why I circled that. Not a multiple choice question.
Or is it?
Maybe. It could be a multiple choice question. One day. Not a multiple. Yeah, you don't have to do any work. You just look at the diagram. You don't need to know the metrics of the angles. You just have to know that they're the same. A is the same as D, and B is the same as E. Two angles are the same. Triangles are similar. So yes. By angle, angles similar. Questions over that? One more. Multiple choice question. I'll pack up. So which of the following statements are true? Select all that apply. First one says, all congruent triangles are similar. What do we think? Is that true? Yeah, it is true. All congruent triangles are similar. Let's draw a congruent triangle. Here are two congruent triangles. What do we know about all the angles of triangles when they're congruent? All the angles are the same, right? So using that angle-angle similarity, this angle and that angle are the same. That two angles are the same, right? That qualifies them as being similar. Their scale factor, we talked about this a little bit, scale factor is just 1. Okay? But they are technically similar. So all figures that are congruent to each other are also similar to each other. Their scale factor is just 1. Because when you multiply something by 1, it doesn't change. So yes, all congruent triangles are similar. All similar triangles are congruent. Yeah. Right? Congruent means everything's the same. Well, if I do a dilation on this figure to make it similar, I'm going to dilate it by a half. Are those the same? No. So similar figures are not congruent, but congruent figures are similar. Their definition. All right triangles are similar. Is this true? I agree. No. Here's why. Can't all different triangles have different angle measurements? Yeah. Doesn't mean they're similar. Right? They both have a 90-degree angle that are the same, but this could be 60 and this could be 30. Well, this could be 45 and that could be 45. They're both right triangles, but do two angles match up? No, only one angle. So no. Not all right triangles are similar. But are all isosceles right triangles similar? Yeah. All isosceles right triangles are similar. Here's the reason why. Isosceles means how many sides are the same? Well, that means the angles across from those sides are also the same. And they both have to equal what? Well, all the angles add up to 180. Right? So I know this angle, 90, plus x. Guys, don't back up. I have you for 4 minutes, and we're backing up. So it's 90 plus x equals 180. So when we solve for x plus x is 2x. 2x is equal to 90. I subtract the 90 over. I divide by 2. So So x is equal to what? 45. So that means in this right isosceles triangle, so the two angles are 45 degrees. Well, in a big isosceles right triangle, aren't they also 45 degrees? Yeah. Doesn't matter how big it is. These angles all have to add up to 180. So to find these angle measurements, we literally would do the exact same math. You have to do the exact same math. You get the exact same answer. So yes, all isosceles right triangles are similar. Because all isosceles right triangles angle measurements are 90, 45, and 45. Doesn't matter how big or how small. Okay. What about a right triangle with a 30-degree angle and a right triangle with a 60-degree angle? Right triangle, right triangle. We'll say this angle is 30 and we'll say this angle is 60. Well, what's the measure of this top angle? 180 minus 90 minus 30, what do we get? 60, right? We'll do two angles match up. Yep, so are they similar? Yep. Last one, two isosceles triangles that have a congruent vertex angle are similar. Well, here are two, go back. Here are two isosceles triangles. The vertex angle is the angle on top, okay, in between the congruent lines. Let's say it is 50 degrees. It's the same logic that we had with isosceles right triangles. When we do the math, it doesn't matter how big the triangles are. If that vertex angle is the same, those base angles are also going to be the same. So yes, the vertex angle is the same. Those base angles have to be the same. So here is practice. Make sure you grab it. It's like 3 questions.